CIET NCERT presents the audiobook Ganit Prakash, Textbook of Mathematics for Grade 6.
Page number 129, Chapter number 6, Perimeter and Area. 6.1 Perimeter. Do you remember what the perimeter of a closed plane figure is? Let us refresh our understanding. The perimeter of any closed plane figure is the distance covered along its boundary when you go around it once. For a polygon, that is, a closed plane figure made up of line segments, the perimeter is simply the sum of the lengths of its all sides. That is, the total distance along its outer boundary. The perimeter of a polygon is equal to the sum of the lengths of its all sides. Let us revise the formulas for the perimeter of rectangle, squares and triangles. Perimeter of a rectangle. Consider a rectangle ABCD whose length and breadth are 12 centimeters and 8 centimeters respectively. What is its perimeter? Perimeter of the rectangle is equal to sum of the lengths of its four sides, that is equal to AB plus BC plus CD plus DA. Here a picture is given of a rectangle ABCD in which AB is equal to 12 centimeters and AD is equal to 8 centimeters. Page number 130. Perimeter is equal to AB plus BC plus AB plus BC. That is equal to 2 into AB plus 2 into BC. That is equal to 2 into within brackets AB plus BC. That is equal to 2 into within brackets 12 centimeters plus 8 centimeters. That is equal to 2 into within brackets 20 centimeters. That is equal to 40 centimeters. As opposite sides of a rectangle are always equal, so AB is equal to CD and AD is equal to BC. From this example, we see that perimeter of a rectangle is equal to length plus breadth plus length plus breadth. Perimeter of a rectangle is equal to 2 into within brackets length plus breadth. The perimeter of a rectangle is twice the sum of its length and breadth. Perimeter of a square. Debojit wants to put colored tape all around a square photo frame of side 1 meter as given here. What will be the length of the colored tape he requires? Since Debojit wants to put the colored tape all around the square photo frame, he needs to find the perimeter of the photo frame. Thus, the length of the tape required is equal to perimeter of the square. That is equal to sum of the lengths of all four sides of the square. That is equal to 1 meter plus 1 meter plus 1 meter plus 1 meter, that is equal to 4 meters. Here we have a picture of a square with side 1 meter given here. Now we know that all four sides of a square are equal in length. Therefore, in place of adding the lengths of each side, we can simply multiply the length of one side by 4. Thus, the length of the tape required is equal to 4 into 1 meter, that is equal to 4 meter. From this example, we see that perimeter of a square is equal to 4 into length of a side. The perimeter of a square is quadruple the length of its side. Page number 131. Perimeter of a triangle. Consider a triangle having 3 given sides of lengths 4 centimeters, 5 centimeters and 7 centimeters. Find its perimeter. Perimeter of triangle is equal to 4 centimeters plus 5 centimeters plus 7 centimeters. That is equal to 16 centimeters. Perimeter of a triangle is equal to sum of the lengths of its 3 sides. There is a picture here of a triangle with sides 5 centimeters, 4 centimeters and 7 centimeters. Example: Akshi wants to put lace all around a rectangular tablecloth that is 3 meters long and 2 meters wide. Find the length of the lace required. There is a picture of Akshi on the page putting the lace along the rectangular tablecloth. Solution: length of the rectangular table cover is equal to 3 meters. Breadth of the rectangular table cover is equal to 2 meters. Akshi wants to put lace all round the tablecloth. Therefore, the length of the lace required will be the perimeter of the rectangular tablecloth. Now, the perimeter of the rectangular tablecloth is equal to 2 into within brackets length plus breadth, that is equal to 2 into within brackets 3 meters plus 2 meters, that is equal to 2 into 5 meters, that is equal to 10 meters. Hence, the length of the lace required is 10 meters. Example: find the distance travelled by Usha if she takes 3 rounds of a square park of side 75 meters. There is a picture of a park which is in the shape of a square and its side is 75 meters. Solution: perimeter of the square park is equal to 4 into length of a side, that is equal to 4 into 75 meters, that is equal to 300 meters. Distance covered by Usha in one round will be equal to 300 meters. Therefore, the total distance travelled by Usha in 3 rounds is equal to 3 into 300 meters, that is equal to 900 meters. Page number 132. Figure it out. Question number 1. Find the missing terms. Part A. Perimeter of a rectangle is equal to 14 centimeters. Breadth is equal to 2 centimeters. Length is equal to how much? Part B. Perimeter of a square is equal to 20 centimeters. Side of the length is equal to how much? Part C. Perimeter of a rectangle is equal to 12 meters. Length is equal to 3 meters. Breadth is equal to how much? Question number 2. A rectangle having side lengths 5 centimeters and 3 centimeters is made using a piece of wire. If the wire is straightened and then bent to form a square, what will be the length of a side of the square? Question number 3. Find the length of the third side of a triangle having a perimeter of 55 centimeters and having two sides of length 20 centimeters and 14 centimeters respectively. Question number 4. What would be the cost of fencing a rectangular park whose length is 150 meters and breadth is 120 meters if the fence cost 40 rupees per meter? Question number 5. A piece of string is 36 centimeters long. What will be the length of each side if it is used to form A. a square, B. a triangle with all sides of equal length, and C. a hexagon, a six-sided closed figure with sides of equal length? Question number 6. A farmer has a rectangular field having length 230 meters and breadth 160 meters. He wants to fence it with 3 rounds of rope as given in the picture. What is the total length of the rope needed? You find a picture of the fence with 3 rounds and a farmer near the field. Page number 133. Matha Pachi. Akshi and Toshi start running along the rectangular tracks as given in the figure. Akshi runs along the outer track and completes 5 rounds. Toshi runs along the inner track and completes 7 rounds. Now they are wondering who ran more. Find out who ran the longer distance. We have length of the inner track as 60 meters and breadth is 30 meters, and for the outer track the length is 70 meters and breadth is 40 meters. Starting point for Toshi and Akshi are given in the picture. Each track is a rectangle. Akshi's track has length 70 meters and breadth 40 meters. Running one complete round on this track would cover 220 meters. That is 2 multiplied by within brackets 70 plus 40 meters. That is equal to 220 meters. This is the distance covered by Akshi in 1 round. Figure it out. Question number 1. Find out the total distance Akshi has covered in 5 rounds. Question number 2. Find out the total distance Toshi has covered in 7 rounds. Who ran a longer distance? Question number 3. Think and mark the positions as directed. A. Mark A at the point where Akshi will be after she ran 250 meters. B. Mark B at the point where Akshi will be after she ran 500 meters. C. Now Akshi ran 1000 meters. How many full rounds has she finished running around her track? Mark her position as C. D. Mark X at the point where Toshi will be after she ran 250 meters. E. Mark Y at the point where Toshi will be after she ran 500 meters. Page number 134. F. Now Toshi ran 1000 meters. How many full rounds has she finished running around her track? Mark her position as Z. Deep dive. In races, usually there is a common finish line for all the runners. Here are two square running tracks with the inner track of 100 meter each side and outer track of 150 meters each side. The common finishing line for both runners is given by the flags in the figure, which are in the center of one of the sides of the tracks. If the total race is of 350 meters, then we have to find out where the starting positions of the two runners should be on these two tracks so that they both have a common finishing line after they run for 350 meters. Mark the starting points of the runner on the inner track as A and the runner on the outer track as B. We have a picture given here showing the common finishing line of the tracks which are square in shape. The outer track has 150 meters as side and the inner square track has 100 meter as its length. Estimate and verify. Take a rough sheet of paper or a sheet of newspaper. Make a few random shapes by cutting the paper in different ways. Estimate the total length of the boundaries of each shape, then use a scale or measuring tape to measure and verify the perimeter for each shape. Akshi says that the perimeter of this triangle shape is 9 units. Toshi says it can be 9 units and the perimeter will be more than 9 units. What do you think? We have a dot structure here in which a triangle is made with 4 dots as 2 sides and a right angle. Akshi says the perimeter is 9 units. Her friend says no, it will be more than 9 units. Page number 135. This figure has lines of two different unit lengths. Measure the lengths of a red line and a blue line. Are they same? We will call the red lines straight lines and the blue lines as diagonal lines. So, the perimeter of this triangle is 6 straight units plus 3 diagonal units. We can write this in a short form as 6s plus 3d units. Write the perimeters of the figures given in terms of straight and diagonal units. We can find picture of the dot pattern and few figures given here. We need to find out the perimeters of the figures given here. Perimeter of a regular polygon. Like squares, closed figures that have all sides and all angles equal are called regular polygons. We studied the sequence of regular polygons as shape sequence in chapter 1. Examples of regular polygons are the equilateral triangle where all three sides and all three angles are equal. Regular pentagon where all five sides and all five angles are equal, etc. Perimeter of an equilateral triangle. We know that for any triangle, its perimeter is sum of all three sides. Using this understanding, we can find the perimeter of an equilateral triangle. We have a figure of an equilateral triangle given here. Width has vertices A, B and C. Perimeter of an equilateral triangle is equal to AB plus BC plus AC. That is equal to AB plus AB plus AB. That is equal to 3 times length of one side. Perimeter of an equilateral triangle is equal to 3 into length of a side. What is the similarity between a square and an equilateral triangle? Page number 136. Find various objects from your surroundings that have regular shapes and find their perimeters. Also, generalize your understanding for the perimeter of other regular polygons. Teacher's note: discuss more about regular polygons and encourage students to come up with a general formula for the perimeter of a regular polygon. Split and join. A rectangular paper chit of dimension 6 cm by 4 cm is cut as given here into 2 equal pieces. These 2 pieces are joined in different ways. We have 2 pictures given here which are representing in different ways. For example, the arrangement A has a perimeter of 28 centimeters. Find out the length of the boundary, that is, the perimeter of each of the other arrangements below. In B, we have a pattern in the form of an inverted L. C, the figure is in the form of inverted T. And D, we have 2 strips arranged side by side. Arrange the 2 pieces to form a figure with a perimeter of 22 centimeters. Page number 137. 6.2 Area. We have studied the areas of closed figures, regular and irregular, in previous grades. Let us recall some key points. The amount of region enclosed by a closed figure is called its area. In previous grades, we arrived at the formula for the area of a rectangle and a square using square grid paper. Do you remember? area of a square is equal to dash, area of a rectangle is equal to dash. Teacher's note: help students in recalling the method of finding the area of a rectangle and a square using grid papers. Provide square grid papers to students and let them come up with the formula. Let's see some real-life problems related to these ideas. Example: a floor is 5 meters long and 4 meters wide. A square carpet of sides 3 meters is laid down on the floor. Find the area of the floor that is not carpeted. Solution: length of the floor is equal to 5 meters. Width of the floor is equal to 4 meters. Area of the floor is equal to length into width, that is equal to 5 meters by 4 meters, that is equal to 20 square meters. Length of the square carpet is equal to 3 meters. Area of the carpet is equal to length into length, that is equal to 3 meters by 3 meters, that is equal to 9 square meters. Hence, the area of the floor laid with carpet is 9 square meters. Therefore, the area of the floor that is not carpeted is area of the floor minus the area of the floor laid with carpet, that is equal to 20 square meters minus 9 square meters, that is equal to 11 square meters. Example: 4 square flower beds, each of side 4 meter, are in 4 corners on a piece of land 12 meters long and 10 meters wide. Find the area of the remaining part of the land. Page number 138. Solution: length of the land L is equal to 12 meters. Width of the land W is equal to 10 meters. Area of the whole land is equal to L into W, that is equal to 12 meters by 10 meters, that is equal to 120 square meters. The side length of each of the 4 square flower beds is S, that is equal to 4 meters. Area of one flower bed is equal to S into S, that is equal to 4 meters into 4 meters, that is equal to 16 square meters. Hence, the area of the 4 flower beds is equal to 4 into 16 square meters, that is equal to 64 square meters. Therefore, the area of the remaining part of the land is area of the complete land minus the area of all 4 flower beds, that is equal to 120 square meters minus 64 square meters, that is equal to 56 square meters. Figure it out. Question number 1. The area of a rectangular garden 25 meters long is 300 square meters. What is the width of the garden? Question number 2. What is the cost of tilling a rectangular plot of land 500 meters long and 200 meters wide at the rate of 8 rupees per 100 square meter? Question number 3. A rectangular coconut grove is 100 meters long and 50 meters wide. If each coconut tree requires 25 square meters, what is the maximum number of trees that can be planted in this grove? Question number 4. By splitting the following figures into rectangles, find their areas. All measurements are given in meters. We find pictures of two figures of which we need to calculate the areas. Page number 139. Figure it out. Cut out the tangram pieces given at the end of your textbook. We find picture of a tangram which is colored here. First, explore and figure out how many pieces have the same area. Question number 2. How many times bigger is shape D as compared to shape C? What is the relationship between shapes C, D and E? Question number 3. Which shape has more area, shape D or F? Give reasons for your answer. Question number 4. Which shape has more area, shape F or G? Give reasons for your answer. Question number 5. What is the area of shape A as compared to shape G? Is it twice as big? 4 times as big? Hint. In the tangram pieces, by placing the shapes over each other, we can find out that shapes A and B have the same area. Shapes C and E have the same area. You would have also figured out that shape D can be exactly covered using shapes C and E, which means shape D has twice the area of shape C or shape E, etc. Question number 6. Can you now figure out the area of the big square formed with all 7 pieces in terms of the area of shape C? Question number 7. Arrange these 7 pieces to form a rectangle. What will be the area of this rectangle in terms of the area of shape C now? Give reasons for your answer. Question number 8. Are the perimeters of the square and the rectangle formed from these 7 pieces different or the same? Give an explanation for your answer. Page number 140. Find the figures given here and guess which one of them has a larger area. We have pictures of 2 figures. In A, we have a curved closed picture, and in figure B, we have edges and appears like a leaf. We can estimate the area of any simple closed shape by using a sheet of squared paper or graph paper where every square measures 1 unit into 1 unit or 1 square unit. To estimate the area, we can trace the shape onto a piece of transparent paper and place the same on a piece of squared or graph paper and then follow the below conventions. First, the area of one full small square of the squared or graph paper is taken as 1 square unit. Second, ignore portions of the area that are less than half a square. Third, if more than half of a square is in a region, just count it as 1 square unit. Fourth, if exactly half the square is counted, take its area as half square unit. Find the area of the following figures. Here we have dot patterns on which different figures are drawn. We need to find the area of those figures. Page number 141. Let's explore. Why is area generally measured using squares? Why can't we use circles instead of squares to find the area? Draw a circle on a graph sheet with diameter, breadth of length 3. Count the squares and use them to estimate the area of the circular region. As you can observe, circles can't be packed tightly without gaps in between. So, it is difficult to get an accurate measurement of area using circles as units. Here, the same rectangle is packed in two different ways with circles. The first one has 42 circles and the second one has 44 circles. In the two pictures, we can find different arrangement of circles such that the first one has 42 circles and the second figure has closely packed 44 circles in the same dimensions. Try using different shapes, triangle and rectangle, to fill the given gap without overlap and gap, and find out the merits associated with using a square shape to find the area rather than another shape. List out the points that make a square the best shape to use to measure area. First one, find the area in square meters of the floor outside of the corridor. Second one, find the area in square meters occupied by your school playground. Let's explore. On a squared grid paper, 1 square is equal to 1 square unit. Make as many rectangles as you can whose lengths and widths are a whole number of units such that the area of the rectangle is 24 square units. A. Which rectangle has the greatest perimeter? B. Which rectangle has the least perimeter? Page number 142. C. If you take a rectangle of area 32 square centimeters, what will your answer be? Given any area, is it possible to predict the shape of the rectangle with the greatest perimeter as well as the least perimeter? Give examples and reason for your answer. 6.3 Area of a triangle. Draw a rectangle on a piece of paper and draw one of its diagonals. Cut the rectangle along that diagonal and get two triangles. Check whether the two triangles overlap each other exactly. Do they have the same area? Try this with more rectangles having different dimensions. You can check this for a square as well. Can you draw any inferences from this exercise? Please write it here in the space provided. Now, see the figures given here. Is the area of the blue rectangle more or less than the area of the yellow triangle, or is it the same? Why? We find here two triangles in the picture such that they are forming a rectangle. In the second figure, two triangles are arranged in such a way that they appear as a triangle. Can you see some relationship between the blue rectangle and the yellow triangle and their areas? Write the relationship here. Teacher's note: help students in articulating their inferences and in defining the relationships they have observed in their own words, gradually leading to a common statement for whole classroom. Recall the definition of a diagonal in the classroom. Draw suitable triangles on grid paper to verify your inferences and relationships observed in the above exercises. Page number 143. Use your understanding from previous grades to calculate the area of any closed figure using grid paper and first one, find the area of the blue triangle BAD. Second, find the area of the red triangle ABE. We can find the pictures of blue triangle BAD and red triangle ABE given on the right side of the page. Both the red and blue triangles have the same area, but they look very different. Area of the rectangle ABCD is equal to dash. So, the area of the triangle BAD is half of the area of the rectangle ABCD. What about triangle ABE? There are two halves of two different rectangles. Area of the triangle ABE is equal to area of the triangle AEF plus area of triangle BEF. Here, the area of the triangle AEF is equal to half of the area of rectangle AFED. Similarly, the area of triangle BEF is equal to half of the area of rectangle BFEC. Thus, the area of the triangle ABE is equal to half of the area of rectangle AFED plus half of the area of rectangle BFEC. Page number 144. That is equal to half of the sum of the areas of the rectangles AFED and BFEC. That is equal to half of the area of rectangle ABCD. You need to write down the conclusion in the space provided. Figure it out. Question 1. Find the areas of the figures given here by dividing them into rectangles and triangles. On this grid paper, we have pictures of various figures given here, of which the areas have to be found out. Page number 145. Making it more or less. Here, pictures of two figures are given. Is there any similarity or difference between the two? Using 9 unit squares, having an area of 9 square units, we have made figures with two different perimeters. The first figure has a perimeter of 12 units and the second has a perimeter of 20 units. Arrange or draw different figures with 9 square units to get other perimeters. Each square should align with at least one other square on at least one side completely, and together all squares should form a single connected figure with no holes. Using 9 unit squares, solve the following. Question number 1. What is the smallest perimeter possible? Question number 2. What is the largest perimeter possible? Question number 3. Make a figure with a perimeter of 18 units. Question number 4. Can you make other shaped figures for each of the above 3 perimeters? Or is there only one shape with that perimeter? What is your reasoning? Let's do something tricky now. We have a figure given here on a squared paper, which is having perimeter of 24 units. Without calculating, all over again, observe, think and find out what will be the change in the perimeter if a new square is attached as given on the right. We have a squared paper here with few squares shaded, and one square which is shaded is to be attached for the new perimeter. Page number 146. Experiment placing this new square at different places and think what the change in perimeter will be. Can you place the square so that the perimeter A increases, B decreases, C stays the same? Here is the house plan of Charan. It is in a rectangular plot. Analyze the plan. What do you notice? We have a picture of a house plan here representing master bedroom 15 feet by 15 feet of area 225 square feet, small bedroom 15 feet by dash feet, area is equal to 180 square feet. Besides, we have a toilet 5 feet by 10 feet. We need to calculate utility area dash feet by dash feet. Then we have kitchen with 15 feet by 12 feet of area 180 square feet. You need to calculate area of the hall. We need to also calculate the area of garden dash feet into dash feet. Parking area dash feet into dash feet, provided we have the side of the length of 30 feet for the house plan. Some of the measurements are given. Part A. Find the missing measurements. Part B. Find out the area of his house. Page number 147. Now find out the missing dimensions and area of Sharan's home. Here is the plan. We have the length of the house as 42 feet. Other dimensions mentioned are master bedroom 12 feet by 15 feet with area 180 square feet. Small bedroom 12 feet by 10 feet, area is equal to dash. Toilet dash feet by dash feet, area is equal to dash. Kitchen 18 feet by 10 feet, area is equal to 180 square feet. Utility area dash feet into dash feet, area is equal to 70 square feet. Entrance area dash feet into dash feet, we need to calculate the area here also. Hall 23 feet by dash feet, area is equal to dash. Some of the measurements are given. Part A, find the missing measurements. Part B, find out the area of his house. What are the dimensions of all the different rooms in Sharan's house? Compare the areas and perimeters of Sharan's house and Charan's house. Page number 148. Area maze puzzles. In each figure, find the missing value of either the length of a side or the area of a region. We have 4 different figures here in which we need to calculate either the length of the side or the area of the region. We have 4 parts A, B, C and D. Page number 149. Figure it out. Question number 1. Give the dimensions of a rectangle whose area is the sum of the areas of these 2 rectangles having measurements 5 meters by 10 meters and 2 meters by 7 meters. Question number 2. The area of a rectangular garden that is 50 meters long is 1000 square meters. Find the width of the garden. Question number 3. The floor of a room is 5 meters long and 4 meters wide. A square carpet whose sides are 3 meters in length is laid on the floor. Find the area that is not carpeted. Question number 4. 4 flower beds having sides 2 meters long and 1 meter wide are dug at the 4 corners of a garden that is 15 meters long and 12 meters wide. How much area is now available for laying down a lawn? Question number 5. Shape A has an area of 18 square units and shape B has an area of 20 square units. Shape A has a longer perimeter than shape B. Draw 2 such shapes satisfying the given conditions. Question number 6. On a page in your book, draw a rectangular border that is 1 centimeter from the top and bottom and 1.5 centimeters from the left and right sides. What is the perimeter of the border? Question number 7. Draw a rectangle of size 12 units by 8 units. Draw another rectangle inside it without touching the outer rectangle that occupies exactly half the area. Question number 8. A square piece of paper is folded in half. The square is then cut into 2 rectangles along the fold. Regardless of the size of the square, one of the following statements is always true. Which statement is true here? A. The area of each rectangle is larger than the area of the square. B. The perimeter of the square is greater than the perimeters of both the rectangles added together. C. The perimeters of both the rectangles added together is always 1.5 times the perimeter of the square. D. The area of the square is always 3 times as large as the areas of both rectangles added together. Page number 150. Summary. The perimeter of a polygon is the sum of the lengths of all its sides. A. The perimeter of a rectangle is twice the sum of its length and width. B. The perimeter of a square is 4 times the length of any one of its sides. The area of a closed figure is the measure of the region enclosed by the figure. Area is generally measured in square units. The area of a rectangle is its length times its width. The area of a square is the length of any one of its sides multiplied by itself. Two closed figures can have the same area with different perimeters or the same perimeter with different areas. Areas of regions can be estimated or even determined exactly by breaking up such regions into unit squares or into more general shaped rectangles and triangles whose areas can be calculated. Chapter number 6 ends here.
Ganit Prakash, you were just listening to this audio book, Textbook of Mathematics for Grade 6. Narration, Swarnlata. Academic Coordinator, Dr. Prakash Vadigar. Technical Coordination, Bati Langlingdo. Sound Recordist, Virendra Rawat. Assistance in Production, Soumya Malik. Directed and produced by Vimlesh Chaudhary. This audiobook is presented to you by CIET NCERT, New Delhi, India.